Hi Fiona, it's just me David, just doing the crypto screencast. This is my screencast, and for part one, where you wanted us to implement the RSA. Implement RSA to create a method which implements the extended Euclidean algorithm. I'll show you now how I did it. I'll show you a few tests first. Show you a few tests. Etc. So I'll just get it from test sheet. So 10 and 17. So this for this first one. And we get x equals minus 5 and y equals 3. So 3 and 19. Uh, 3, 19. And we get x equals minus 6 and y equals 1. And 17 and 26. 26, and then that equals x will be minus 3 and y equals 2. Then try some bigger numbers. 139, 3980. That gives us x equals 19 and y equals minus 3. I'll try this other bigger number. 2971. So 2971. What's that again? 403. 29. Shit. Yeah, short-term memory. 2971. 4032. That's it for the bigger numbers. And so I'll show you how I did it. Explain how I did it. I can just X this. So basically, in this part, we just get the numbers of the user. Then the first numbers of the user. And then, as we know that whatever A and B is always divided to itself, so I've already automatically done the 0 equals x and the 1 equals y, and also the last x equals 1 and y 0 equals 0. And so I done a while loop so that it will keep doing the equation until it equals 0. So b, if not, equals 0. So then a and b is passed into the function. So then b divided by a will give you q, which is like, just say the number that you'll use to, like, let's say like a, it'll be b minus q brackets a, the equivalent to that. Yeah, and then that's just calculating the modulo which will give me the remainder. So then as we go down the equation, b will equal a, and then the remainder will equal b, and then the x will equals the temp. So then, and then as we go sideways right to the box, x which was 0 divided by q, which was the number that we got through a and b, and then minus the last x, which was 1, which will give us x, and then we do the same thing for y, and then should print out last x and y, basically. So that's it for part 1. And then part 2, you wanted us to get the implement RSA crypto system and then should be able to generate keys, encrypt and decrypt messages. So basically that is my part 2 here. And then and I forgot actually to show this bit to show if these ones for part A for part 1 to show that they still work actually. So 1645. Yeah. That gives us x minus 7 and y equals 1, and then the greatest common divisor equals 3. And then I'll do that for one more. 11 and 649. 649. Yeah, and the greatest common divisor is 11. Excuse me. Yeah. And so for the part 2, I will show you how to do that and the code. What's this? So basically for the part 2, this bit over here basically generates the text from the user. The text from the user. And so this here generates the random numbers, which is given to D and E. And so this part here checks if P and Q are co-prime to E. Yeah, co-prime to E. And so this N over here is scan phi or pi, and then actually this here checks if it is co-prime to E. Sorry, and then yes, taking to the top proper prime is a number which is prime with the high likelihood. So then for the last bit is the bit that actually encrypts and decrypts the message. So you send a plain text. Which turns it into bytes, and then the ciphertext basically decrypts it, and then gets it back, and then encrypts it. The plain text basically sends it into bytes, and then that encrypts the message, and then it brings it back, and then decrypts the message to bring it to the original message. And so this prints out, and also this just prints out like the P, Q, E, I, and ND, and then this will be the original message, and then this will be the decrypted message. Yeah. So I'm just gonna test that with these. So message. Okay. Just try with a number, then 25. Uh, 25. Then, as you can see, our original text or number, and then our decrypted one, and then this shows the P, Q, E, F, I, and D. So we're going to try another tester. Going to try 135. See how it goes for us. And then 135. Yep, everything's fine. And as you can see, the number is longer. Go for a bigger number. So let me copy this and put it in there. Yeah. And that's the original text, original number. Obviously, will be longer as well than the other two. So now we're gonna try a letter. Try a small letter. Write this down. I'm gonna try to pick a letter, copy the letter. There it is, that working. And now we're gonna try hello, all caps. Hello. Yep. It's working fine. And we're gonna try hot two. Hot equals 2. Yep, works perfectly. And do one last one. Hello. See? There it is there. There's the results, the output working perfectly, and then the code. And yep, that's me. Thanks very much.